Good day, everyone. My name is Ali Bhatt. I'm a project scientist and a project manager for sustainability-related projects at the Pavement Research Center at University of California. So I'll be presenting to you today the environmental life cycle assessment for pavements tool that we have developed for Caltrans and for local government, and we are developing one for the Federal Aviation Administration as well. Why do we want to quantify? That's the first question. So when we talk about sustainability, we have to have quantifiable measures so that we kind of have an understanding of whether we are making something sustainable or whether it's not. Is it just reducing the greenhouse gas emissions and making sure that we are recycling? Is that something that we can answer? Well, yes, if we use quantifiable measures. Another important thing to take into account is the full system analysis. So we have to include the complete life cycle based decision making. When we talk about the full system, what I mean to say is we have to include all the stages of the life cycle of that product or a system or of that activity. A very generalized LCA framework for pavements. We have the material stage. We have the construction stage. Some people like putting it together, construction and maintenance. We have the use stage, and then we have the end of life stage. In order for our materials to get processed, you have to have fuels. You have to have electricity. You may have recyclable materials. And of course, you have to have a pavement design as well as the pavement dimensions. They act as the input for our framework. And as an output, of course, we get our pavement as a whole, but we are also getting airborne, waterborne, landborne emissions. We may get recyclable materials, and in some cases, you might get energy as well. So for the last decade, the Pavement Research Center has been working quite a lot on developing models, collecting data, and our end product is the Environmental Lifecycle Assessment for Pavements tool. It's a web-based tool for transport infrastructure LCA tool. The reason we call it transport infrastructure is right now we have roads, but we are looking into getting the bridges in this tool as well. The tool is capable to model the life cycle of any pavement project. The database library is developed based on the California-specific inventories. And this includes the materials and mixes, construction equipment and activities, transportation modes, as well as the use stage impacts. And we do have IRI equations, the excess fuel consumption due to roughness equations, and of course you need fuel to move your vehicle on top of the pavement. And then we have end of life scenarios that you can also evaluate. There are total 18 different impact categories that can be quantified in there. That's Tracy plus the 15804 energy, renewable and non-renewable energy impacts. We have had 2 sessions of getting our data and models reviewed by 3 external reviewers who are kind of well known in the pavement world here, and they do have enough knowledge of LCA. All this information that I'm presenting, by the way, that's available in the papers that we have published, the reports, Caltrans reports that we have published, and the references will be there in one of the slides at the end, which you can kind of download once you get the handouts for these presentations. So when we started developing this model back in early 2010, the only well-developed databases that were available were mostly proprietary. You were either looking at CIMA-Pro, EcoInvent, or Gabi if you really wanted your data sets to be kind of much more closer to completeness. But now, because of federal LCA Commons effort, we do have now the publicly available data. So because we were developing it for Caltrans early in 2015, so we had a license agreement with ThinkStep, who developed Gabi, now owned by Safera, by the way. And the license only allows Caltrans and UC Davis people to use the tool. But we are right now working on replacing that proprietary data with the publicly available data, especially from the federal LCA Commons. So we do want industry, we do want anyone who is interested to use the tool to be able to use the tool. And yeah, we are trying our best. Actually, in a year or two, we want this tool to get into hands of other people as well. That's how our tool looks like. That's the main page. You need to register the tool, your username and account in the tool. That person is going to have his own database, which others cannot see. If they want to share that, there are other options that are available on the tool as well. On the front page, you're also going to see there are certain models, generalized models that we are also presenting. One of the examples there is of the Pavement model. That's just an example. I don't expect you to read what's there on the screen there. But the idea here is that there are several unit processes, number of unit processes. In this Pavement project, as an example, there are 306 total unit processes that are being computed to get that Pavement project evaluation done. So there is a lot going on in the background. The whole process of running eLCAP is also kind of summarized in a flow diagram there as well. Of course, I understand that you are not allowed to use it right now, but as I said, by end of this year or early next year, we do hope that this is going to get into the hands of other people as well. Our databases, as I informed earlier, were critically reviewed by 3 external reviewers, and the results were published along with the review process reports as well in Caltrans reports. Some of the example of these impacts are actually shown in this table. I think one of the interesting one that I think you would probably want to see here is the comparison of different kind of cements that are available, the global warming potential for different cement types. So PCA has published 2 EPDs back in 2016 and 21. This is what their number looks like. What we did was we went back to the LCA of cement reports, and then we took out some of the kiln data, and we used that using the electricity mix and the fuel mixes of California. And then we kind of recalculated some of these values. All the assumptions for all these different cement types, how the calculations were done, the models themselves, all are available actually in that report if you are interested to kind of look at. We also have Portland limestone cement inventory there as well, in case somebody is interested to kind of look at this material as well. In order for the data, anybody to have confidence in that data, you have to have a properly defined data quality assessment method. We were also part of the LCA PAVE development team. That's the Federal Highways LCA tool, Excel-based LCA tool. And this was actually one of our tasks where we were supposed to come up with the data quality assessment method. So we used US Environmental Protection Agency's report. They had a very basic data quality matrix developed, but we kind of made it applicable for our product use as well. So we have the data quality indicators right there on the left. We have sub-indicators there as well. And then those indicators are described briefly, and then we have the scoring system. So in eLCAP, if you would, even there in the report, by the way, as well, we have done this data quality assessment for any data that we are using. So if there is none available by the producer, we kind of go back and check and see if we are able to score that data. And based on this, one could have a little bit of confidence in what data they are using to do their evaluation. And that's the continuation. We also have the time period, location, technology, and other stuff as well. LCA-PAVE has a little bit of synthesized one, but we kept the comprehensive one that we actually are using for eLCAP. In eLCAP, you can also create your own mixes, add your own materials. You can also add equipment, construction equipment, and transportation vehicles as well. So because, as I said, this is California-based specific data that we are using, so we were to use MFAC, which is California Air Resource Board's database instead of MOVE's, and even off-road for equipment emissions as well. An example that you can create your own concrete mix designs in there as well. You have all those ingredients. You can change the mix design based on percentage mass, and you can also change the energy values for this as well. And the program is going to be able to quantify the impacts for you. We do have reclaimed asphalt pavement and recycled concrete aggregate databases there as well. Instead of adding those materials just as is, we have different scenarios that are actually defined. And a user can select the scenario which he is going to be actually, which he has for his particular project. So scenario means is it in-place recycling? Are we talking about getting the material from stockpiles at a plant or at a different location, and you're bringing it into your own plant and creating your mixes? And then for each of these scenarios, there are certain equipment that you need as well, and they are all defined in the report. There are several construction activities. Few of them I have listed there. You can have HMA pavements, JPCP, CRCP, aggregate bases, lean concrete base, cement lime treated bases, and several other. You can also look at grinding, milling, asphalt pavements, and all this actually could be done using the tool. We have also linked the location database of Caltrans as well as the traffic database of Caltrans to our tool as well. So the minimum information that is needed to run eLCAP is you need to know where your project is. And once you know where your project is, the traffic is going to be preloaded in because we know what the traffic is there. And then the only other information you need to know is what are you doing? Are you adding a layer or are you removing a layer? And what your design kind of looks like. So you just put in this minimum information and you are actually able to quantify the impacts. Of course, if you are an advanced user, you can create your own mixes, create your own materials, and do a lot more. So I have done this example where I have put a location in there, and it shows me that there are 2 lanes in this direction at this location, and this is how the traffic looks like. And in case you are interested to change this scenario, you can even edit and change the cross-section. You can add paved shoulders, unpaved shoulders, whatever your project kind of looks like. There are several tables that are available in there. These are the input tables. As I said, the minimum information required is, what are you doing? Are you constructing a new pavement? Are you doing a maintenance? When is that event occurring? And what does your initial IRI looks like? And then whether you are adding a layer, or you are removing a layer, or you're grinding. Whatever activity you are doing needs to go in there, and you define your thickness, the materials and transportation and equipment to build or remove that layer automatically appears here in the other tables. And the default values of how much time a certain equipment needs to run to build that pavement, or what is the distance, default distance to getting the materials from to the site, to maybe to the plant, all those assumptions have actually already been filled in for you if you are a beginner. If, as I said, if you're an advanced user, you can change anything here. Using the same information, you can design your case, whatever you have. Another quick example is example of cradle to lathe, where I try to do a JPCP and a CRCP pavement. So you can do comparisons in eLCAP as well if you have 2 designs. Of course, the analysis period and the location has to be the same. If you have those 2 things the same, those checks are okayed, you can actually do the comparisons for 2 designs, 2 different pavements as well. Another example I would like to show here is, this is also the outputs, by the way, from eLCAP. So you can also do rehab activity, then you have a preservation, another rehab, another preservation. You can compare these different scenarios with other scenarios that you might have. So in this particular case, I have rehabilitation and preservations cycles for 40 years. And then I have rehabilitation only for 40 years. So these kind of analysis can actually be very well done in eLCAP. This is an interesting slide and a bit controversial. So on the x-axis, you see cumulative greenhouse gas emissions. On the on the y-axis, and on the x-axis, you have time. So what I'm trying to actually show here is that in a low traffic scenario, there is something that is seen here. If you see this circle, there is some material construction and transportation activity. That's a vertical line on the y-axis. So that's an activity, that's an event that has happened. And then for the next 5 years, you have traffic that has been running on this pavement. So you see 3 curves here. The yellow one is the one, of course, you need fuel to run your vehicle, to push your vehicle on the pavement. But then you have pavement effect, pavement roughness, that is actually causing an excess fuel consumption. You add these together, you get the total use stage emissions. So what is interesting going on here is that when you take the percentages of this, the material, construction, and equipment all make 0.1% of the total. And the use stage here is almost 96%, and 3% comes from actually the roughness. So the reason I actually wanted to show this slide here was that if we really want to make a change in the transportation sector, bringing down those greenhouse gas emissions that we talk about, the major change has to occur in the use stage. It has to occur. You have to stop using the fossil fuels to run your vehicles. Then you are really going to see the change. Then somebody would ask, why are we actually talking about all these material stages and EPDs and all this? We are playing our part. So everybody has to play their part. Of course, it's pretty good that we do need to bring down our emissions in our sector there as well. So everybody has to play their part, but at the end of the day, use stage really, really matters. And this is a very simple example. If I make this a high traffic scenario, this goes even further down. So life cycle assessment can be used to quantify environmental impacts. And there is guidance available by federal highway documents. We have state documents as well in order to develop LCA frameworks. We are at a stage where we are able to develop tools. I mentioned LCA Pave for federal highways. That's a tool that is available you can use. And we want this tool to soon come into your hands as well. But right now, Caltrans and at UC Davis, this tool is being used. Then we have a very important point here that if we get the primary data from the industry and industry starts helping getting this data available, our LCAs could have meaningful and impactful results. As we had disclaimer from the ACI, I have a disclaimer there as well, which you can quickly read. I don't want to take time on this one. The references, as I mentioned, are available they will be available in the handouts. Thank you.